Hey, this is Clover, and it is a beautiful snowy day today here in the Netherlands, and we're going to be solving a classic Sudoku called A Touch of Class from Philip Newman, originally posted on January 14th, 2024 in GAS. And before I get started, I will warn you, Philip originally posted this alongside some very cryptic notes that he took while he was originally setting it. I believe he started setting it in a business meeting with pencil and paper, and he challenged us to figure out what exactly those notes were referring to. There's some kind of underlying trick or technique or setup to this puzzle, and I will warn you that I do not know what it is. I'm hoping that Philip will reveal it to us. I do understand how to solve this puzzle. I think it has a really beautiful, clean solve path, and I'm looking forward to showing it to you. I also suspect that there is something kind of theoretical going on here that's really interesting. Philip is the classic Sudoku expert on the team, and I'm hoping that he will tell all of us what that is a little bit later. But let's just focus on getting it solved for now. So, first thing I notice, we have this classic setup where we have a 2x2 region that's either all full or all empty. And when it's all full, that very often signals that we're going to have a hidden pair in that same region. Sure enough, got a 7 and 9 here, which rule 7 and 9 out of these cells, so we're going to place a 7-9 pair in those cells. Symmetrically, we have a 3 and 5 here, which rule 3 and 5 out of these cells, so we're going to place a 3 and 5 into these cells. Now, because I have two 3s in rows 1 and 2, there's only one position left for 3 in this region, and I can finish up the region with a 6-8 pair. Here I have two 9s that rule 9 out of these cells, so I can place a 1-2 pair here. So, the next thing we can do here, let's see. There's only one position for 8 in column 7, because there are 8s already in columns 8 and 9. So let's place an 8 there, and that will resolve our 6-8 pair. Similarly, there's only one position for a 2 in column 3, which is right here. That will resolve our 1 and 2. Now we have two 1s that both look into region 7 and rule 1 out of all of these cells. So let's place a 1 here. And we have two 6s that both look into region 3 and rule a 6 out of all of these cells. So let's place a 6 there. This 1 and 2 keep us from placing 1 and 2 in any of these cells, so we have to place a 1-2 pair here, and we're going to finish this region up with a 7 and 9, which we can place because there's already a 7 in column 8. Here we have a 6 and 8, so we place a 6-8 pair here, and we still need a 3 and 5, and again we can place those because we have a 5 already in column 2. Let's pencil in our last two digits here. In fact, we don't need to pencil mark because we can see there's only one remaining position for 7 in this row. There's a 7 here already, so we're going to put a 7 there, and our last digit is a 4. Here we still need to place a 4 and a 5. The 5 can't go there because of this 5, so that will be our 5, and that will be our 4. So let's look at these columns. We still need a 1, 4, and 5 in this column. There's a 1 and 5 in this row, so this will be our 4, and then that will be a 1-5 pair. We need a 4, 6, and 7 in this column, and there are 6 and 7 in this row, so that's our 4, and then this will be a 6-7 pair. And now comes, I think, the trickiest move of the puzzle. We're going to find some very sneaky naked digits, and by a naked digit, a naked single, what I mean is that we have a cell where we can rule every digit out of that cell except for 1. And that is what we refer to as a naked single. And where we're going to find it is in this column, and then again in this column. So in this column, we still need 4 digits. We need 1, 2, 3, and 5. But in this row, we can rule out 1, 2, and 5. So the only digit that is allowed to go into this orange cell at all is a 3. That's the only digit that is not seen already in that cell. So that makes this a 5 and makes this a 3. And our last two digits here will be 1 and 2. And our last two digits here will be 5 and 9, which we can place because we already have a 5 in row 6. We're going to do the same thing here. We have 1, 2, 3, 4, and 5, so we need 6, 7, 8, and 9. But we already have 6, 7, 8 in this row, so we can place a naked 9. And these cells are going to contain 6 and 8. These need to contain 3 and 7, and we can place those immediately because of the 7 in row 4. Now, this row, we still need 1, 2, and 5, but we already have a 1 and 5 accounted for in this region, so that will become a 2. That's going to resolve these pairs. Here we still need a 6, 7, and 8, but we already have 6 and 7 accounted for in the region, so that'll be our 8. And we're almost totally done with the middle band of the puzzle. So we now need a 3, a 4, and a 9. 4 can only go in the middle position. Then there's a 3 here, which places a 3 there. And there goes our 9. So now let's start looking at some of these vertical columns. In this column, we still need 1, 3, 6, and 9. And I'm looking for rows where those are restricted. For instance, we can't have a 3 or 9 here, so that's 1 or 6. We can't have a 3 or 6 here, so that's 1 or 9. In fact, I'm noticing now that the only place we can put a 3 in this column, because there's a 3 here and a 3 here, is going to be this cell. And then this also can't be a 9, so the only position for a 9 in this column is right here. Let's see if we can do something similar with the other empty columns. So we need 1, 2, 7, and 8 here. We can't place a 7 in these two cells or here due to the 7 in the row, so that's now our 7. Now we can't place a 1 or 2 in this position, so this will have to be our 8, and we finally get to deal with our 6, 8 pair. These are now going to contain 1 and 2, and there are other ways of handling this, but I kind of think this is cute. This 1, 2 pair keeps this from being a 1 because 1 and 2 have to be in these two cells. So that's a 6 and a 1, and that untangles the pairs. And now we're just writing in digits to finish up. We're just getting the last digit in each row and column. And obviously the timer is incorrect there. That is how we solve Philip Newman's A Touch of Class. Hope you enjoyed that one. I definitely did. And I'm hoping that Philip will reveal whatever the theoretical secret of this puzzle is shortly.